So welcome to this latest video on 162 Maths, and in this video we're going over some GCSE Maths past exam questions related to the area and circumference of a circle. Now as always, I'll include a link to the questions that we go through in this video in the description below, and I'll also include some lesson links that go over this topic in greater detail. Now before we get started, let's just have a quick overview over what it is we need to revise when revising this topic. So the first thing is you need to know the formulas, and the formulas are not given to you in the exam. Now you also need to know the formulas involving the diameter and the radius. So here for the circumference, that's either going to be pi times the diameter or 2 pi r. And it doesn't really matter which one you use. You tend to use pi times d when you know the diameter, and you use 2 pi r if you know the radius, but it's not difficult to switch between the two. For the area, the formula is pi times r squared. So again, these formulas are not going to be given to you, so it is important that you do learn them. The next one is to be able to work with semicircles and quarter circles. Now if you're given a semicircle, remember that if you're working at the perimeter, that it's going to be this arc length, which is this here, plus the straight edge. So always be mindful of adding the edges, and I would always recommend that you label each of the parts of the perimeter and then work them out separately, but just be mindful of that. And the same thing when you've got a quarter circle, to make sure that you're adding 2r, so the total perimeter is going to be 2 pi r, which is the perimeter of the full circle, divided by 4, because that will give me what this part here is. But then I also then need to add 2 lots of r as for the 2 straight edges. The next thing you then need to know is the links between arc length and sector area. Now arc length is theta over 360 multiplied by 2 pi r, and sector area is theta over 360 multiplied by pi r squared, and that in itself has a separate topic test, which again I'll include a link in the description. You also need to be able to do reverse questions. So this is when you're either given the circumference of a circle or the perimeter, and you need to work out what r is or what the diameter is. And likewise, if you're given the area of a circle, reverse questions are when you've got to find the radius or even the diameter as well. So make sure you have good practice of reverse questions. You also need to practice worded problems. So a question like, how many revolutions will a bike of a wheel of, let's say, 20 centimeters make in the space of 3 kilometers? So again, worded problems like that you need to be aware of. And also, even though this is more likely to appear on a non-calculated paper, always make sure you practice writing your answer in terms of pi. Now sometimes a question might ask you to give your answer as a rounded number to either decimal places or significant figures, but if it doesn't, and you've got a Casio calculator, which often gives you the exact value where possible, you may want to leave your answer in terms of pi. So again, be mindful of that. Another area where you might leave your answer in terms of pi is if you are working out part of a question where accuracy is going to be key. So rather than rounding your answer partway through a question, you may want to leave it in terms of pi, as that's going to be in its most exact form. So now let's get started on some past exam questions. Now again, a little reminder, if you want access to these questions, all you need to do is just simply click on the link in the description. So looking at question 1, it says that a circle has a radius of 2.8 centimeters. Work out the area of the circle. So for this, I'm going to use the formula of pi r squared. So it's going to be pi times 2.8 squared. So on the calculator, if I just type in pi times 2.8 squared, it gives me an answer of 196 over 25 pi. So that's the answer in exact form. Or if I press the decimal equivalent button, it gives me 24.6, and that's to 1 decimal place. Now notice how in this question it doesn't mention anything about rounding, so I can write my answer in any form that I like. So again, you might want to just leave your answer in terms of pi, so you don't have to be concerned about rounding it incorrectly. But if you do round, always make sure you're stating what you've rounded it to. Then moving on to question 2, it says, let me just zoom in so we can actually see it on the screen. It says a circle has a radius of 10.7. It says work out the length of the circumference, give your answer to 1 decimal place. So for this, we know the radius. So then using 2 pi r, it's going to be 2 times pi times 10.7. Now alternately, if I just write down the answer, so let me just type that into my calculator, so 2 times pi times 10.7, and that gives me an answer of 107 over 5 pi, but as a decimal it's 67.23 blah blah blah, so it's going to be 67.2 centimeters, and that's to 1 decimal place. Alternately, you could have worked out what the diameter is, which is 10.7 times 2, which is 21.4. So it's going to be pi times 21.4, which again still gives me the same answer. Moving on to question 3, it says the diagram shows a quarter circle of radius of 12. Work out the area of the shape. Well, as this is a quarter circle, that's the formula for the area of a full circle. So if I divide that by 4, it'll give me the area of a quarter circle. So it's going to be pi times 12 squared, all divided by 4. And again, if I stick that into my calculator, I get an answer of 36 pi, which would be a valid answer because there's no mention of how they want me to write the answer. So I can write 36 pi, or I can write the decimal equivalent, which is 113.1, and that's to 1 decimal place. Alternatively, you could just copy all the numbers on your calculator and you'll still get full marks for it. Moving on to question 4, it says the wheel has a diameter of 0.4 meters. Work out the circumference. So again, it's going to be pi times the diameter. So it's going to be pi multiplied by 0.4. So putting that straight into my calculator, I get an answer of 2/5 pi, or working it out as a decimal of 1.26, and that's to 2 decimal places. Again, you could write 1.3, but to make sure that you're writing to 1 decimal place. Question 4b, it says work out the number of complete turns the wheel travels in 2.9 kilometers. Well, 2.9 kilometers is 2,900 meters. Now you want to work with the same units. So then from this, I've got 2,900 divided by 1.26. So then let's just type that in. Well, it's actually still on my calculator. So if I do 2900 divided by the ands, I get an exact value of 2307.746679. So we're looking for complete turns. So it's going to be 2307. Moving on to question 5, it says 2 identical circles fit inside a rectangle as shown. The length of the rectangle is 26 centimeters. Work out the area of the shaded section. So for this, the shaded section is equal to the area of the rectangle minus the area of the circles times 2. So then working out the area of the rectangle, well, if 2 circles have a total length of 26, then one is going to have a length of 13. So that means that the diameter of the circle is going to be 13. So the width of the rectangle is going to be 13. So the area of the rectangle is going to be 13 times 26, which on the calculator gives me an answer of 338. Then the area of a circle with a radius of 6.5 is going to be pi times 6.5 squared. So 6.5 squared times pi gives me an answer of 169 divided by 4 pi. Now I need 2 of those, so if I multiply that by 2, I get 169 divided by 2 pi. So that means then to work out the area of the shaded area, I take away those 2 amounts. And again, if you want to work with decimals, that's entirely up to you. So 338 minus 169 over 2 pi. And typing that into the calculator gives me an answer of 72.5, and that's going to be centimetres squared to 1 decimal place. Question 6, it says the diagram shows a shape made of two semicircles. The radius of a large semicircle is 8 centimeters, and it says work out the perimeter of the shape. Give your answer in terms of pi. So for this, if I just label or color code the two sections, so that orange length I know is 8. I need to work out this blue length, and I then need to work out this pink length here. Actually, let's use different color. Let's go for green, it's a little bit more contrasting. There we go. Now this is basically going to be 2 pi r divided by 2. So here we know that the diameter, well, it's actually, let's use pi diameter, so it's pi times the diameter divided by 2. So that's going to be pi times 8 divided by 2. So this length here is 4 pi. Then looking at the blue length, well, that's going to have a diameter of 16. So that's going to be pi times 16 divided by 2, which equals 8 pi. So this length here is 8 pi. So to work out the total perimeter, it's going to be 8 plus 4 pi plus 8 pi, which gives me an answer of 12 pi plus 8. And there is my answer in terms of pi. Then moving on to question 7, it says that a large spring has a diameter of 15 centimeters. It is made from 20 hoops of steel cable. Steel cable costs £3.60 per metre. How many springs can be made from £1,000? So first of all, let's work out the circumference of the hoop. So the circumference, which is going to be pi times 15, which is 15 pi, and 15 pi is 47.12, and that's going to be in centimeters. Now we then need to work out what the cost of one hoop is going to be. So from this we can then see that, well, it is made from 20 hoops of steel, so the total spring is going to be 20 times 47.12, and that's in centimeters. So 20 times 47.12, and that is 942.4 centimeters. So then what we then need to do is work out the cost of one spring. So that's going to be £3.60 multiplied, well, it's per meter, so then that is going to be, so if I convert this length into meters, that's going to be 9.424 meters. So the cost of that, if I multiply that by £3.60, and that's going to come to a total of £33.92. So then all I want to then do is divide 1000 by 33.92. So 1000 divided by 33.92, and that gives me an answer of 29.48. So how many springs can be made? The answer is 29 springs. Then moving on to question 8, it says the diagram shows a rectangle inside a semicircle. The rectangle has dimensions of 6 by 4. Work out the shaded area. Give your answer in terms of pi. So for this, we know that this length here is 6, and we know that this length here is 4. Now the shaded area equals the area of the semicircle minus the area of the rectangle. So what I need to do is I need to find those two things there. Now to work out the area of the semicircle, I need to work out what the radius is going to be. Now this is what I need. So that is r. Now looking at that triangle that I've just drawn, I can then work out what this is, which is half the rectangle, so that's going to be 3. So taking that little triangle that I've just drawn out, so I've got 4, 3, and that's r. Using Pythagoras, I get r squared equals 4 squared plus 3 squared. So r squared equals, and that's going to be 25. So therefore r equals 5. So then from this, I can then work out the area of the rectangle. So the area of the rectangle is going to be 6 times 4, which is 24. And then the area of the semicircle is going to be using pi r squared divided by 2. So it's pi times 5 squared divided by 2, which is 25 pi divided by 2. So then to work out the area, the shaded area, it's simply going to be the area of the rectangle, which is 24, minus the area of the semicircle, which is 25 pi over 2, and there is my final answer, and that's in centimetres squared. So moving on to our last question, it says the shape is made from circles. The diameter of the large circle is twice the diameter of the small circle. What fraction of the larger circle is shaded? So what the fraction is actually asking me, it's basically the shaded area divided by the area of the large circle. So these are the two bits of information that I need to know. So to work this out, if I start by stating that the larger circle, now if I just pick a number for the larger circle, so let's say for argument's sake that it's got a diameter of 20 centimeters. So that means that the diameter of the smaller circle will have a diameter of 10 centimeters because it's half the size. So then going back to this, we know that the radius of the large circle will be 10 centimeters and the radius of the smaller circle will be 5 centimeters. Now here the area of the large circle is going to be pi times the radius squared, which is 10 squared, which is 100 pi. Now the area of the small circle is going to be pi times 5 squared, which is 25 pi. So that means that the shaded area is going to be 100 pi minus 25 pi, which equals 75 pi, because the shaded area is always the big shape, take away the smaller one. So then if I know that the shaded area is 75, I know that the larger circle has got a area of 100 pi, so that means that the fraction is going to be 75 pi divided by 100 pi, and then the pi's cancel out, and so all I've got is 75 over 100, which dividing both numbers by 25 gives me a simplified fraction of 3/4, and there we go.